Good afternoon, everyone. I'll try to keep it as interesting as possible. I know it's after lunch, it's Friday afternoon, so I'll try to be quick and painless. Yes, so who am I? I used to work at the RIPE NCC. Many of you might have been at one of the training courses I used to run. I worked at the Internet Society. I run the CHIX and IXP.GE, that's in Georgia, run the NOC there, so I like to help get the internet in different places. I'm in the RIPE program committee, and by the way, while I'm here, we have elections coming up, so if you want to join the RIPE program committee, have a look. I'm in the EuroIX program committee and DKNOG. I'm on the SWINOG board in Switzerland because I live in Zurich, and I'm part of the Italian FreeBSD users group. And more important for this talk, I run an autonomous system. I have a neighbor that many of you might know about. That's Pim van Pelt, who's been posting a lot about the work he's been doing on VPP and DPDK and running his autonomous system. And basically, we run BGP between our houses. So that's how lucky we are. So what is this talk about? I have done some research. A year ago, very same place here, we had Job Snijders, and he came over and we were having a chat, and he told me that he saw something. He thought there was something there, like some ISPs, some networks injecting BGP information into, RPKI information into BGP, and that he wanted to have a look. So we were both busy for some time, but then we figured out then later on that there is a problem, and here at the end of the presentation, you'll see that we have a proposal for a best current operational practice and at the IETF to moderate the issue. So this time, though, DNS is innocent. So it's not always DNS. So we have the three main protocols. Well, we have RPKI, BGP, and DNS. This time, DNS is innocent, so we shouldn't talk about them. But what it is about, it's about RPKI. So before I go into the details of what I've seen, let me align everyone on how RPKI works. You have two sides. One is the signing part, and the other one is the validation part. So they're totally independent. You see there's a line in the middle, and you can sign something. You can sign your ROAs, I will show you in a moment, without doing any validation, or you could do any validation you want without having signed your own ROAs. But what is in a ROA? We have, I like to call them route objects on steroids, because they have a little bit more than a route object. You have a prefix, you have an origin ASN, and anyone is free to put whatever they want in there. And you have a max prefix, max length. Let's forget about that. Let's focus on the prefix and the origin ASN. And then we look at the ROAs, and they've been increasing. This is data about Denmark. You see, in 2020 there was a growth, an immediate growth, and I think it was maybe I haven't had time to look at that, but it probably was Telia or a big ISP who created their ROAs at the time. So we are at a good percentage of coverage, getting there for both V4 and V6. But I'm showing you these. These are graphs that you could see in any country. So there's been growth in RPKI. And with more entities creating their ROAs, we might end up with more issues. One of them is the one I'm going to explain to you in a moment. Others are the fact that we have more and more data in RPKI, and we still are in the learning phase about how to treat it. So we have repositories, we have the 5 RIRs who have these ROAs, this data. You have a validator, that's a software you run on your servers, or some people like to use an external service I wouldn't recommend that. And with that, you push data to your router. So you have on one side ROAs, statements that say where what you should see in BGP, and then you have BGP announcements. And when you get the mix of the two, you can have your routers help your routers make better routing decisions. So you can easily avoid the networks that are invalid. But what does that mean? We have validation states. And while I'm going to focus on the second part, so what's BGP origin validation, and I see Gerardo recognizing the slides from when I was at the RIPE-NCC. They're the same exact ones, basically. You have a ROA, and the ROA can be either valid or invalid. When it is invalid in this case, in the ROA validation, is when the certificate's expired, the signature's expired, so there is a problem with the chain of trust. But let's focus on when a ROA is valid. So we have data that gets into our validator, and then a BGP announcement at that point can have 3 different states. It can be valid, which is good. It can be invalid, which is bad, which means the origin ASN, the prefix length, they don't match what is in the ROAs, and then we should discard those networks. And then we have not found. Not found is when we don't have a ROA to look at, so we don't have any data to evaluate the BGP announcement that's coming in. So this is our baseline now. Imagine we have 3 states. For every BGP announcement, we look at one of these. We have one of these states. Hopefully, we never see invalids. And then we have on the other side communities. Communities are a way to tag something in a BGP announcement. We put a value, like original communities are 32 bits, so we can put 16 bits, what was the original size of autonomous system numbers. And then we have a second part, another 16 bits as an identifier to tag something. And we can use communities to attribute, to give values, to give additional information, to attach additional information to a BGP announcement. We have normal communities, and then we have large communities. And large communities give us much bigger address space for doing the same, for having the same function. 32 bits for the ASN, 32 bits for a function, and 32 bits for something else we want. So normally you would see large communities being first the AS number of the ASN that tagged them, second the ASN of the neighbor they tagged them for, and then a parameter that's a value, a random value that they picked that defines something. So imagine at one point you could use communities to tag, I don't know, ROV, route origin validation. And people thought about that. So we have a problem because people started doing that. And it was actually something that was recommended at the time, some years ago. But consider that communities are a transitive attribute. So if I tag something in one AS and I send the data over an eBGP connection, that can go everywhere. So what happens when we start doing this and when we have ROV states that change all the time? Because people create ROAs, people delete ROAs all the time. So how does this affect the default-free zone? How many updates do we see with this? And that's where we started investigating. The first part was figuring out where this idea came from. And I agreed with him, but the responsible person is in the room for this outdated documentation, and it's sitting there in a corner, and it's Melchior. No, I'm joking. There is Melchior wrote a book some years ago. It was the very first book, or still the only book you can find about how to set up RPKI. And it's focused on Juniper, but it gives you an idea of how to do it in general. now, he told me yesterday the PDF was updated to include all the new shiny objects you have, but the web part, the one you can find if you Google for it, recommends still to install the RPKI validator from the RIPE-NCC, which was basically abandoned a few years ago. And the recommendation you see in there is to tag your BGP announcements with the communities related to the ROV states. So I promised Melchior that we can work together to fix this. But then let me show you what we found. Well, before we get into that, while I was doing this research, we had Chinese one evening, and I found this, and I thought it was right on point. Stay calm and fair, although it is difficult. Because, well, it was difficult at the beginning, but so. We did a first stage. My initial idea was, we do have a hint that there is an operator, 3356, that tags ROV states in BGP. So let me, I did a very, very first preliminary round with BGP Stream, but then I had to change laptop, and BGP Stream is basically broken now. So I had to move over to BGP Kit, which I would recommend. So the idea was, take a random RIB output from route views, check to see if in the RIB I can see any route tagged with the specific community that we saw from one operator. And while I was doing this, I was approached by a friend who had some issues with their networks. Actually, they're in the Faroe Islands, so I helped them debug a few things. And then I ended up looking at on the 1299 Looking Glass, and there I was, wait, they also do tagging for ROV. So I added that to my list. And so when I look at this, I have 1299 430, that is a community that gives me RPKI state valid, 431 that is unknown or not found. And then I have 3 entries for 3356, that is 901, 902, and 903. And as I sat here, I hope I'm never going to see 902 in the wild, which means somebody would be propagating invalid RPKI data. That's good. So I did my first run, route views on the 27th of October, 2023 at 22. And I did find some occurrences of these entries. I didn't find anything on 1299. And that was weird. But so it was good that I didn't see anything that was supposed to be invalid. But I had nothing, no visibility of anything from AS 1299. So I went over and I looked at other route views collectors. And I did find something also on route view 6, which focuses on V6, but I did find something there. And so this gave me a bit of confidence. So we do have something. So I set up a job to check for BGP updates. So this way, with this I went through the BGP updates. I used RIS Live, set it up to give me a total of the updates and the number of updates that contained these specific communities. So what I saw was, you see there's a baseline, the blue here for V6. There's a baseline of hundreds of thousands of entries that come in and churn every time with the target communities. And the number is a bit higher in V4. And sometimes, depending on the time of the day, you have churns of updates that carry these communities. Keep in mind that this is for RIS Live. There's a question, yes? This is 1 day, 24 hours, yes. This is 24 hours with a distinction between what contained the target and what didn't contain the target communities. So this gave me an idea, like, okay, there are these. So let's go ahead and use a test prefix instead. I have a /29 I could use for this, so IPv6. It's announced. I can have it announced by my own AS number. I have peering at SwissIX. I have a couple of transits peering at CHIX, so can be easily propagated. And I also put together a script that updated my ROAs every 6 hours. So every 6 hours, it would create or remove the ROAs, depending if they were there. And then I created a specific filter that would only tell me what was happening to my own prefix. Because what I wanted to spot here was, are these the ones from 1299 and 3350, 56, sorry, the only networks that are doing this, that are tagging my routes with states? And I found something interesting. So I didn't see anything from 1299 or 3356 because I'm not a customer, most likely, but I spotted Coloclu. Has anybody ever heard of Coloclu before? It's an it's a not, yes? Job is involved in Coloclu, yes. Well, Job was involved. Pim, my neighbor, is involved, and actually I talked to him about it. You can see that between the first and the second entry, there is a difference. There is that 8283 102. And 102 says, accepted from peer because of valid ROA. So when 102 is present, it means there's a valid ROA associated with it, and then once I deleted it, it went away, and so there was a re-announcement because there was a different community in there. So this means there is something. There are a bunch of other networks that I saw doing a similar thing. The problem here is, for example, for one of them, I could go on their website and check which communities they had, and that matched what I could see. For many others, I didn't find any documentation. So I have the feeling there are more, but I can't tell you exactly because I don't have access to their own documentation. I sent some emails to those ASNs I've seen doing it, but I haven't received any replies because in many cases I'm not a customer, so they wouldn't tell me which networks, which communities they have. But as you can see, we do have operators who do this tagging. So what are the conclusions? There is definitely a number of operators doing this. There are people signaling RPKI over BGP communities. The amount of noise is it's notable. It's about 15% of the total updates that I could see consistently during the day. But what I'm saying is, with more and more operators enabling ROV, this might become a bigger and bigger issue because more people will start tagging more communities. So the end discussion we had was we need some BCP documents to recommend not doing this, or at least keep them internal to your network and don't propagate these communities. So we have a BCOP draft, BCP draft, guidance to avoid carrying RPKI validation state in transitive BGP path attributes. There's a link to the data tracker, and you can go and have a look. There is a mention of this study that I did. And what about future work? RISC-Live has some limitations where, for example, I couldn't look at large communities because BGP RISC-Live doesn't give you large communities by default. It gives you the full packet, the full BGP message. So I went back and implemented a very lightweight BGP message parser to do that, but I still haven't had the time to run it for a day because a lot of manual intervention is required. As I told you, you can see things like usually you would have the ROA update, so removal or addition, and usually an hour and a half roughly after the the addition or the removal of the ROA, you would see some churn in BGP updates with the target prefix. But then distinguishing what is what. For example, I would see a lot of traffic, a lot of new updates with new new communities by the DKNOG route servers, for example. And I know Bernd, I need to still talk about this with Bernd, but I would see a lot of that. And I would see a bunch of other ASNs providing different updates. But going from there to being sure it is about the RPKI signaling in there, that is a bit harder because I need to either check their documentation or RPSL and hope for things to be there. And then, so I'm going to repeat the prefix test using large communities because there's a lot more to see. But I haven't had time yet, and this is coming up. And that is basically it. So I think I'm 2 minutes away from the end of the talk, so I'm accepting questions then.
Thank you, Max.
Thank you. I see one. I see it up there. Lasse.
Hi, I'm Lasse from Telia. I'm not sure I really caught the point here. You are removing the RPKI information every 6 hours?
I was adding a ROA or
adding
removing a ROA.
But that's not the usual behavior of anyone, right? So you're doing this as a beacon.
Exactly.
So do you feel that a usual behavior of you are either RPKI valid or you either have a ROA or not? So is there any additional churn to the BGP updates in a normal case then?
No, the thing is we don't think so, but in the BCP we highlighted that, for example, a loss of if you have a network that has this behavior, imagine that network loses all the validators or the validator they're running. So everything goes from either valid or not found to just being all not found. You would have a high churn of updates because everything turns into not found. And then the moment the validator comes back, you will have another big churn of updates because then you have all the valids that become valid. And that is a potential issue because you would see a large number of updates all in one go. But normally there is that 10, 15, 17% of updates that I see carrying these let's call them well-known communities. And I still haven't done the work to see if I can match them to a change in ROAs, because that one would be the definitive one. That one requires modifying an RPKI RTR library to see if I can get all the data together.
Thank you.
You're welcome.
Any more questions? I think we're good. Thank you, Max.
Okay, thank you.